Right, so we're going to start with pHs of strong bases. We did pH of strong acids, and all we had to do really was do the minus log of the concentration of H+. To get the pH of a strong base, we have to effectively do the same thing. So we have to do minus log of the concentration of H+. But to do that, we only get given the concentration of OH minuses, or firstly, we work out the concentration of OH minuses. So if we were to have 0.1 mole, let's say MgOH2, we'll get 1 mole of Dm minus 3. So we've got a concentration of our base, and we now want a concentration of our hydroxide ions. So if we were to say our MgOH2 is equal to 0.1, so now our concentration of OH minus ions will be equal to 0.2, because we've got 2 OH minuses for every 1 molecule. So we've got a concentration of 0.2 OH minuses, but we want the concentration of H pluses. So what we're going to do is we're going to use the ionic product of water. So if you remember, we have Kw, and that was equal to the product of H plus and the product of OH minus. And for our room temperature, we had Kw equals 1.00 times 10 to the minus 14. So we have the ionic product of water, that's the information we have. We have the concentration of OH minus ions. So we have this number, we have this number, and we want this number. So all we have to do is we have to sub in. So 1.00 times 10 to the minus 14 is equal to H plus concentration multiplied by the OH concentration, 0.2. So now we can just rearrange. So go 1.00 times 10 to the minus 14 divided by 0.2 is equal to the concentration of H plus ions. And if you work that out, you get 5 times 10 to the minus 14. So we've now got a concentration of H plus ions. And all we have to do is minus log 10 of 5 times 10 to the minus 14. And if you put that in your calculator, you will get 13.30. Now we've got a pH for our base. And you will do that every single time you need to work out the pH of a strong base. You work out the concentration of OH minuses, you put it into the ionic product of water equation, you'll get given this number, or you should get given this number, because it will change with temperature. Then you substitute the numbers you know, so you know Kw, you've worked out the concentration of OH minuses, so you put that in. Simple rearranging, you get the concentration of your protons, and then you do the minus log of your concentration of protons, and you get the pH. For a sense check, remember your strong pHs are going to have a high pH. So if your pH turns out to be a really low number, or maybe below 6 or below 8, it's probably going to be wrong. You're looking for a number around 13 to 14. And remember, for pH, we must have it to 2 decimal places. Right, so what we're going to do is you're going to do task 3, which is on page 7 of that booklet. I'll give you about 10-15 minutes to do that. If any questions, do ask. I might mute my camera though.